All right, this video is the second of two videos. It basically talks about how to write a system of equations or inequalities, right, to represent the graph. So notice up here, I should actually change this real quick in my typing. Write a system of equations to represent the graph. Well, we actually want a system of inequalities. And the reason I know that we want these to be inequalities is that notice the shaded region here. It's not just three lines that we're drawing. We're drawing a shaded region in between, right? We want to be below that top line, above the bottom one, and left of this vertical dashed line. So actually, let's go ahead and start with the vertical dashed line. Okay. So we're going to write up a system. So I'm going to just draw a little bracket here so I know I've got lots of space. Remember that any vertical line is always represented by x equal to the value that every point on that line has. And if we think about it, these are all over where x equals 2. Notice I'm 2 units right of the origin. So again, this is the line x equals 2. Now, because it's a dashed line, I'm not actually going to write an equal sign in there, though, because the dashed line is telling me that line is not really there. I just want all the points to the left of that, or all of the points where x would be 1 or 0 or -1, everywhere to the left of or less than 2. If I drew up x is less than 2, it would be this dashed line, and I would have shaded the entire left side of that graph, everywhere left of the dashed line. Now, I'm restricted though. I've got to write up a couple more equations. Let's go ahead and do this next line here. So again, we'll call this one line number 1. Let's go ahead and do line number 2 now. This positively sloped line, right? From left to right, it's rising. Well, the big thing we want to remember there, the easiest way to write up an equation is to write up a y equals mx plus b equation. So I'm going to go ahead and say y. Notice that this one is, right, a solid line, number 2 here. This is a solid line up here, which means I want to be equal to, right, my slope. Well, if I just go ahead and count it out, it looks like I'm going up 1, right 1, up 1, right 1. So this looks like a slope, right, of vertical 1 divided by horizontally 1, or basically a slope of 1. So I'm just going to say 1x. And now I need to add on my y-intercept, right? If I'm thinking about y equals mx plus b, that y-intercept is where we cross the y-axis. And it looks here, if we're counting by ones, according to this label, like we went up 2 units, right? We're going to cross here at exactly 2. Now notice we're also shaded below this line. So I want all of the points that are less than my line, less than my formula. I want all of my y values to be less than or equal to x plus 2. Remember, that's the other easy way to kind of determine your graph. If you're shaded below the line, it meant that y, if it's all by itself, is less than my line, less than the way I found my line, my formula for my line. Let's go ahead and do the last one down here. Let's go ahead and we'll do this one in blue just so we can denote it on the graph here. Notice from point to point, I'm going to go from down 2 units, so call that -2, and I'm traveling right 3 units. So if we go ahead and judge our slope, let's go ahead and start with the right side here. Again, I'm going to say y. It's a solid line equal to the slope down 2, right 3 for every x, right? Or essentially down 2/3 for every x value. And now we need to find our y-intercept. Well, that idea that we went down 2/3 for every x value is going to be very helpful, because I really want to get from here, right, to here. I need to find this point. Well, I only traveled x1 to the right for x. I only went 1 unit right, which means that x traveled 1 unit, which means the slope of my line should have traveled down 2/3 of a unit. Now, if you want to double check that, we can do the good old-fashioned way of taking a point that's on my line. So notice this point over here. This is the point-4, 2. I could plug in to y equals mx plus b 2 for the y value equal to negative 2/3 times negative 4 plus b. Well, in that case, this is 2 equals negative times negative will be positive 8/3 plus b. And if you do a little calculator work, or if you just do it in your head, again, 2 is the same thing as 6/3. So if I subtract that 8/3, I'm going to get a negative 2/3, which is kind of what we thought, to go from 0 on the x-axis down 2/3 and right 1. That would be my x-intercept. So it looks like not only was our slope negative 2/3, just so happens that where the line is, we also have a y-intercept of negative 2/3. The only other thing we need to judge, again, it was a solid line. We have our equal sign going here. We also need to be shaded above, right? We're left of the dashed line, below line number 2, but we're going to be above line number 3 here, which means that y is greater than or equal to our line. Again, you can always take 0, 0 and plug it into each of these equations. Any point that you pick in this sort of orangish region here should make all 3 inequalities true. So if you have any questions on that, feel free. Grab a point, plug them into all 3, check and see. See if they're always true. And if you have any other questions, talk to your teacher, and have a great day.